Good morning, happy Bowtie Friday. Today on ETH.BUILD we're going to talk about gas. So we know that we've got these blocks being mined, right? And they are forming a chain by referencing the previous block. And we know that this block is basically a block of transactions. So we have lots of transactions coming in. And we also have this mem pool, this transaction pool over here that has pending transactions, right? So when you want to send a transaction, you basically set up the to and the from, and you put some incentive here. You put some gas along with it, and then you sign the whole thing off, right? So that transaction contains who it's going to, some data maybe, and then also an incentive for the miner to put you into the block, and you sign all of that. So then when the miner comes along, he's just going to pick the best transactions in the block, in the pool, and fill them in the block. So basically all of these transactions in the pool are bidding with their gas price to get included into the block, and the higher the traffic, that higher that bid is going to be. Okay, so let's just dive into making a transaction first and show that. So I've got a custom wallet I put together, but it's basically just like the wallet module. And I'm going to push in one gas. So right now, if you were to ask the API what the gas price is, you need to be at about 12.36 gwei to get your transaction into the blocks. And we can see that by, if we come over here, we can look at, here's the transaction pool. 88 is the highest that someone is willing to pay, but then we'll see blocks get mined here, and we'll watch and see. So the lowest gas that got into block number, what was it, 220, was about 13. Now it's up to 18. See that? So if I put in a gas price at 1 and I hit send here, so I sign that transaction, I send it off to the network, it's going to land in the mem pool, the transaction pool, and we're going to be watching for it here. But what we're going to see is, sure enough, this gas price is going to be 1, right? 1 gwei. And the lowest possible gas price mined into the block in that last block was 8. So this transaction is basically just going to hang out here for a while. Oh, look at 1 gas. We probably could have snuck in there. We didn't get in, though. We didn't get in. Okay, so we're going to increase this. I'm just going to put this at 15.001. Actually, let's just go with 12. Let's just go with the 12.36666, right? All right, and let's resubmit it. So same transaction, same nonce, right? We're going to take the same exact transaction. We're going to crank the gas up a little bit, and then we're going to sign it again and put it out on the network. And look at that. The network realizes that we're bidding higher. And now we're sitting in the pool, but with a lot more attractive gas price, and we'll see that disappear pretty quickly. There we go. We can see that 9 got mined into the block. Let's see if I can do this quick enough. I could quickly scroll down and maybe find our weird 11 number. What were I think I saw it there just for a second. Okay, so basically you're bidding at to get your transaction into the block. That's your gas price. Okay, but there's also this gas limit, and let's explore that a little bit more. And I think I'll actually just kind of destroy this and start from scratch here. Okay, so let's bring in a wallet module, and let's also bring in a chain, and let's just work off of, instead of talking to the mainnet like we just were, let's just go talk to our testnet. And I'm even going to put that just. This is just like a nice thing to have, is to just start setting up this stuff to be a little bit more copy pastable. Okay, and we're going to create a hash, and this will be Alice Gas will be her name, and that will be what we use for her private key. So she's going to need to send to someone. Okay, and the value will be 0 for now. And we won't send any data yet, but let's maybe just get some text ready for the data field. And our gas limit will just be 2100, which is fine, which is the smallest amount. and then we'll send this off. Okay, so, oh, you didn't like that. What didn't, oh, there's no to address, right? Okay, so we need another wallet. Let's grab another, all of this, and let's have this down here, and this will be Bob Gas. So we've got Alice Gas and Bob Gas, and now Bob has an address, and Alice has an address. Okay, and so Alice is going to send to Bob Gas. Okay, cool. Now that should sign. There we go. Okay, so that probably just created a transaction from Alice to Bob. Let's look at their balances too, huh? Okay. Cool. All right. So let's see. What's happening here? Alice is sending a transaction to Bob, and we can see the gas. What we're wanting to know is the gas used. There we go. Okay. So this number tells us how much gas it took Alice, okay? So there's a gas price, and then there's an amount of gas, and those two things are going to be sort of separate, and actually they're multiplied for how much you end up paying. But, so it's 2,100 for Alice to send. Let's actually hit the faucet and get ourselves a little grip of funds. You can do that by just double-clicking into your wallet. Now we'll see we have quite a bit more, right? Okay, so what we want to do, we have 0.07, and he has 0.2. Okay, so let's say, so no matter what, if Alice wants to send a tiny amount to Bob, or Alice wants to send, you know, most of what she has to Bob, no matter what, it's always going to end up, we'll see the transaction hash change, but no matter what, we're always sending that 2,100, okay? So that gas price we used on the mainnet, that like 12 gwei, right? And that's our gas price, and then our gas limit is basically, if you want to just send from one person to another, 2,100 is like the flat rate. It's 2,100 gas, right? But then it gets way more interesting as you start adding stuff. Okay, so let's say I wanted to send some data to Bob. So now Alice is going to send, oh, this is going to have to be in hex. Alice is going to send this hex string along with the transaction. Actually, we'll send 0 value. The value won't even matter, right? It's just this string that we're going to send, and we're just going to send hello Bob. Okay, so along with our transaction, we're going to send some data, and this probably won't let me do this. Yeah, exceeds limit. Because we're sending some more gas, we're going to need to add some more here, right? So let's beef it up to 30,000 for our gas limit, and let's hit send. So again, here we're on a test net, so our gas price doesn't matter. So we're probably just using whatever the gas price is on mainnet. It doesn't really matter. We can go look. Yes, we're basically asking for the fast price, and we're using mainnet gas prices, but we could have our gas price at 1. This is a test net. There's no competition to get into the block. But the gas limit still holds, and we need to make sure we have enough gas to get the transaction sent. So this worked, and that spent 2114, right? So if I do hello Bob, this is a longer message. Watch what happens to the gas that ends up getting used. There we go. It fails at 21.5. So if I were, or it finishes and costs 21.5. So it costs just a little bit more. So this call data is pretty cheap, technically, going in. For 2,100 to send anything, it's 21.5 to send, you know, this nice long message, right? Well, it could be a lot longer. It gets whatever. Anyways, it's relatively cheap to add a little bit of call data on top of this transaction if we're already paying 2,100 for it. And if this message gets longer and longer, we see this number increase. And if we cut our limit down beyond, if we go to 21.5, it is going to fail. Yeah, okay. But if we go just above that, what, like 21,900, let's see if this goes through. I'm assuming it did. I didn't even watch we're watching, I guess maybe the hash should change right here. Yep, hash is changing. Transactions going through. Bob's receiving his transactions. Okay, so that is call data. So to send a plain vanilla transaction, 21,000 every time, right? 21,000 gas. I think I said 2,100 before. It's 21,000. 21,000 gas to send a transaction. Then anything else on top of that, you'll have to pay for this extra call data. But it gets even more interesting than that. So since everything is a transaction, right? In those blocks are just transactions. Everything is a transaction. Whether you're sending something to someone, you're sending data to someone, or you're sending data to no one, which is deploying a contract, or you're sending data to a contract, which is interacting with a contract. And that's where gas is going to get really interesting. So what we'll do is we'll set up to code ourselves a little smart contract. Okay, so this is going to be called, we'll just call it gas test, right? And we'll need a text item called gas text. Okay, and does that compile? It does. Okay, we could deploy that. Okay, so this very, very, very empty contract compiles to this bytecode right here, right? Now, if Bob shoves that bytecode in his data field and has an empty 2 and an empty value, we should be able to deploy this contract just like that. Uh-oh. Guess what? It's mad at us for our gas limit. Okay? So it's trying to send 2100 or whatever the base is, but we're trying to send this extra data, right? We're sending this extra data in the transaction. And so it's going to cost us a little bit more, right? Okay, so we got to pay, we know we have to pay the extra. Let's set this to 60,000 maybe. Let's see if that goes. Oh, compile. Send. It's still not liking it. All right, let's double it up. Let's go to 120,000. Okay, there we go. I think we got a receipt. Yes. All right. And that also means with the receipt, we got a contract address. Yes, we do. Okay, so let me just save that contract address and we'll display it here. And it should be the same thing that comes out of my wallet right there. Yeah, okay, cool. So Bob has deployed a completely useless contract, but it cost us how much gas was used. 67, see that, 67066, and that's we're not executing anything here, so that's just getting that call data on there. But okay, here we go. Let's put, first of all, let's set up a uint public counter, okay, and let's just initialize it to 0. All right, how much does that cost to deploy? Let's try it. Let's compile and deploy that. What is this change to? 83, so another 20,000. Okay, so what we can talk about here is basically the Ethereum yellow paper. So if you want to really learn more, check out the Ethereum yellow paper. And inside of the Ethereum yellow paper, there are all the different commands and what they cost in gas. And what we just did was this store right here. What we just did is we stored a value on chain, which was our uint in our contract, and it cost us a whole 20,000. Most of these are very cheap, but storage is expensive, okay? So there's all these opcodes. So we write our code, and that is compiled to opcodes, and those opcodes cost money. And it basically just runs in this execution environment, doing what we're asking it to do, but this gas limit says only go so far. And why that is because of something called a halting problem. If we were to write some function, it's impossible to tell if that function is going to run forever or not without just running it, right? It's a deterministic smart contract, but you still have this thing called a halting problem that basically says we don't know if this thing is going to run forever, and we don't want people's execution environments to get hung up. So we have this notion of a gas limit. So there's the gas price, and there's how much I'm willing to bid on getting my transaction in there, and it multiplies by a gas limit, which is how far I'm willing to go to make sure this transaction gets there. So you hear a lot of the analogy of like a letter, right, with a stamp on it, kind of incentivizing, but this would be, your stamp would be not only an amount but how far you're willing to let the mailman go looking, right? Like if you're just sending the letter down the street, it's a small amount, don't go very far. But if it's going, across the world, you send a little bit more in your gas limit, right? And so that gas limit is about this like execution that we're going to about. So it's going to do. It's not just the call data that comes through in the transaction, but it's actually doing stuff within the execution environment, and that's costing you gas. So there's the gas to send something, 2100. There's the gas to put the call data, which is that extra amount that we paid for here. Then there's the extra amount, same thing to put a contract on chain, but then to interact with a contract, that we're going to pay extra. Okay, so let's call this. So we paid the 20,000 to set up the storage, but now let's have a set counter function that takes in a new counter number, I guess, and we'll just let anybody set it. Why not? And basically we'll say counter equals underscore counter, right? Does that compile? We good? Okay, so now anybody can set it up. Let's see if it deploys. Let's see how much it costs us. There we go. Okay, so it costs about 96. Okay, so now we can set up a contract and we can go interact with this contract. Okay. So let's see, I'm probably going to let's just grab all of Bob's stuff here and move it down here. Let's grab another Bob wallet. Okay. And we'll use that to interface with this contract. So we'll do blockchain there. Okay, the contract is at this address. Cool. And with this ABI, now watch this, it should, boop, it's like, oh, you've got these two functions. You've got counter, which lets you just get what the counter is set to right now, and we'll keep watching that. It's at 0. And then there's a set counter, which lets us pass in a number to set the counter to, and this gives us the bytecode that will be the data that we interact with our contract with. Okay, cool. So the to address will be our contract now. So we're going to send a transaction to our contract with no value in it, and we're going to have to set a gas limit high enough that it's able to execute whatever it needs to do in here, right? So right now it's just setting a counter, so it's going to be updating a value. I know from the yellow paper that this right here, this S store, is going to cost me 5,000. I've set it up already and paid the 20,000 already, so this little action right here is going to cost 5,000. So I'm guessing all of this is going to be something like let's say 26 to get it there, and then the 5 like 30 something. I bet it's going to be in the young 30s. Let's see. All right, so let's just set it to 35,000. It's probably going to be more than that. Gas limit. All right, and we're going to be watching for a receipt so we can see what the gas used was. All right, let's put a button in here, and let's make sure we still have a balance. This is the right guy. Okay. All right, Bob. Let's do this. All right, it did. It went. Transaction on. Wait, what did we set? Let's set it to something. That's weird. All right, let's set the counter to 5. Let's do this again. Okay, it ran out of gas. So I wonder. All right, so let's go 50. 35 was not enough. There we go. It was 4146 is what it used. Okay, so let's pull that object out and let's look at that gas used. 41. So I was way off by like 10 grand. There's probably other stuff going on there that I don't know about. I don't know much about the inner workings of it, but you're kind of getting what's going on here. Is we've got this. So now let's do this. Let's do this on a for loop. Okay, so it's 41,000 to set the counter. What if we just like set the counter 10 times? Right? Like just some blatant loop where we're just like doing more work than we should be. We're going to be calling that 5,000 over and over again for 10. So this is like that loop right there. That's 50,000 right there. Yes, right? So this is going to cost extra. I'm just going to put my the total I want it to go at 150, right? So we know it's going to run for about 50. We know this is going to be an extra 30. We provide some extra padding there to make sure, but basically we're making sure it doesn't run and use all the gas in the whole block and cost us way too much money, right? But this should work. Let's see. Let's set the counter to 10, 150. Okay, so now this is going to cost more, right? Because it's going to. Whoa! Why was that cheaper? What did I do? What just happened? Okay, the data, is this right? Maybe because we've already set it once, it was cheaper to set the second time. 10, let's see what happens. If I set this to 20, oh, wait, I didn't deploy my contract. Okay, so that was an interesting thing, but it's cheaper to update this value, right? Now the counter is 20, that's super cheap. Yeah, 26, okay. But what I need to do is compile and deploy this contract, or nothing works. Okay, so now we're going to deploy the same contract. It's going to update the counter, but this time it's going to update the counter 10 times. So the transaction is exactly the same size, right? We're calling that same exact function. The transaction is exactly this size, just like it was before. But this time it's going to execute more, and we're going to have to pay for that execution. So this should be a lot higher number now. There we go, 49,000. Well, that was kind of like the other one. All right, let's go bigger. Let's take this thing through 25 iterations. Let's go 50 iterations. Just gonna burn gas. We're just wasting gas. So every single miner on the network would have to receive this transaction and run through this loop, updating that memory, and every single one would get the same exact answer, and they would all hold that answer. That's how this decentralized network works, right? So like we're paying for all those miners to do all this this execution, so we have to pay for it. There we go. So what happens now when we call this number? There we go, 84,000. There we go. So we're burning a bunch, right? So to deploy the contract, it was like 100,000, right? And then to hit it and update it and do 50 writes, it was still less than what it cost to deploy the contract. But pretty soon you could kind of see how gas is going to become very important, and the network's going to get clogged up a little bit, and we only have so much. It was what, 10 million? So we could deploy like 10 of these contracts per block, right? So really not that, like there's room there, but like it's getting smaller. So that's gas. Basically, we've got gas price and gas limit. And your gas price is used to bid to get you into that block, and your gas limit is telling that miner how far to go in terms of executing that code. And if it's just sending money, it's just 21,000, no problem. If you're just sending some data, you just basically pay a small rate to get that call data on. But then if you're executing code with that call data, then that's where that halting problem comes in, and that's where it gets interesting. And it basically just lets you call codes as long as you have the gas within your limit, and as soon as you hit the gas limit, everything reverts and reverses. So that's it. That is a long-winded discussion on gas for Bowtie Friday on ETH.BUILD. Thanks for coming along. I will save this and have it ready if you'd like to check it out. Thank you. Happy Bowtie Friday.